Today we're going to take a look at angles created outside of a circle. And before we do that, there's going to be one more addition of vocabulary word to this unit, and that's a secant. So a secant is basically like a chord, but it's extended. So for example, this would be considered to be a secant. It goes through the circle twice at exactly 2 points. And when we have if we have two secants and they create an angle, well, we have some, we have a way that we could figure out what that angle measure is, or maybe a secant and a tangent. So this would be a tangent if it touches exactly once. And that's what we're going to look at today. We're going to look at angles that are created outside of a circle. So again, real quick, secants intersect the circle exactly twice. So for example, AB would be a secant, whereas BC would be a tangent because it touches only once. So we're going to talk about, before we get into the measure of those angles outside the circle, we'll take a look at the way that the arcs are intercepted, because that's pretty important to figure out. So it says first part A, they tell us we have circle O, AB is a secant, AC is a secant, and DE is a tangent because it only touches exactly once at K. The first question asks us what two arcs are intercepted by both AB, secant AB, and secant AC. So if we take a look at those two secants, we actually get, because it's outside the circle, we get two arcs that are intercepted. So we want to find the arcs that are intercepted. So this arc right here, FG, is intercepted, but also arc KH is intercepted. So we have two arcs that are intercepted here. And that would be arc, that would be arc FG and arc KH. Second part says what arc is intersected by secant AC. So by secant AC and tangent DE when it creates angle AKD. So we're also looking at this tangent. And we want to specifically look at the arc that's intercepted when it creates angle AKD, so this angle right here. Now the arc that's intercepted, well, it kind of starts at F and goes all the way around to K. So the arc that's intercepted is arc FK. Okay, so for this part, we could say arc FK. And then it says, what arc do those same segments intercept when they form AKE? Okay, well now we're looking at this angle right here. Okay, if it's AKE, then it's starting here but going around this way. So that's going to be arc F. We'll use 3 letters because it's the major arc. So we'll say FHK. So arc FHK. Now it's important to figure out what arcs are intercepted, because then we won't be able, if we don't know it, then we won't be able to use our rules. So speaking of rules, when angles are formed outside of a circle, created by tangents or secants, any combination of those, it's going to be the difference between the two arcs and then divide that by 2. So arc minus arc divided by 2. So if we take a look at, we'll just kind of go through these. We have an angle created by a secant and a secant. The rule to figure out what the measure of this angle over here would be, the rule to figure out the measure of angle P is going to be arc CD minus arc AB, and then divided by 2. If we look at the next one, this one is created as another angle outside the circle, but it's created by a tangent and a secant, but it's still the same rule, which is pretty nice. It's going to be arc, so arc AC minus arc AB, and then divided by 2. And lastly, we're taking a look at an angle outside of a circle created by 2 tangents. But since it's outside the circle, it's still going to be the same rule, which is arc, so arc ACB minus arc AB, and then divided by 2. So we'll just go ahead and take a look at a couple of examples here. So we have 2 tangents outside the circle, arc minus arc divided by 2. So if we just do that real quick, it's arc 260 minus 100 divided by 2. So that's 130 divided by 2. So that's going to be an angle of 65 degrees. So angle B is 65. If we look at our next one, that's one created by 2 secants. Created by 2 secants, they intercept arc AE, and it intercepts arc BD. So once again, it's going to be arc minus arc divided by 2. So 60 divided by 2, which is 30 degrees. And the last one is created by a tangent and a secant. So a tangent and a secant, arc minus arc divided by 2. So 100 minus 30, and then divided by 2. 70 divided by 2 is 35 degrees. And it's as simple as that. If it's outside, arc minus arc divided by 2. Okay, so we'll go ahead and we'll just find the value of x for each of these. So now we have 2 tangents. The 2 tangents intercept this arc, which is 260 degrees, and this arc. Well, the whole circle makes up 360 degrees, so you need to know that this arc right here would need to be 100. Okay, now that we have both arcs, we can go ahead and do arc minus arc divided by 2, and that gives us our angle. So that's going to be 160 divided by 2, which is 80 degrees. Our next one, we have 2 secants, and we have an angle outside. So subtract our 2 arcs that are intercepted, 150 minus 70, and then we'll divide that by 2. So 80 divided by 2, that's going to be 40 degrees. So this next one, we have the angle this time. So we have the angle, so we know 80 degrees is going to equal the bigger arc, so 185, minus the smaller arc, and then divide that by 2. So we can put this over 1 and cross multiply. So we're getting 160 equals 185 minus x. We'll get negative 25 equals negative x. So that smaller arc would have to then be 25. If we did a quick check, 185 minus 25 is 160. 160 divided by 2, yeah, that checks out, and that is 80. Okay, our next one, we have the angle outside, it's 45 degrees, and that's going to equal the bigger arc, which we don't know is x, minus the smaller arc, and then divide by 2. So we get 90 equals x minus 90, add 90, so the missing arc has to be 180 degrees. So moving on, we have some variables here. We need to actually figure out what the arcs measure. We can go ahead and do that because we know this is y, this is 5y, this is y, and this is 2y. So we have the entire circle. The entire circle adds up to 360 degrees. So y plus 5y plus y plus 2y needs to equal 360 degrees. So 5, 6, 7, 9y equals 360 degrees. So y needs to be, 40 degrees. Okay, now that we know that y is 40 degrees, we can go ahead and substitute everything in. So this is going to be 200. Substitute 40 in for y. This is going to be 80. We don't need to really know these, but this would be 40 and this would be 40. Okay, now we have enough information where we could do arc minus arc divided by 2. So 200 minus 80 divided by 2 is going to give us angle x. So 120 divided by 2 equals x. X equals 60. And this last one, well, we don't have all of the arc measurements, but there is something that's pretty important here. So if you notice, this secant goes through the center of the circle, which means it cuts it in half. So this is really a semicircle. So we could say 3y plus y has to equal 180 degrees. So 3y plus y is 4y equals 180. So y equals 45. And then we can go ahead and substitute in. This is 45. And this is going to be 135. Okay, and we could do arc minus arc divided by 2 now, because we have this arc and then we have the other arc. So the two arcs subtract and divide by 2. So that's 90 divided by 2, which is 45 degrees. Okay, we'll just take a look at 2 more questions here. So sometimes they don't give you a diagram and you really need to be able to know the vocabulary and draw it yourself. So we have 2 secants intersect outside of a circle to form an angle that measures 38 degrees. So let's try to draw that. 2 secants intersect outside of a circle. So just draw one secant to start. So here's a secant. Then let's draw a second secant and they need to intersect. So here's a second secant and it does intersect, and that's going to form an angle that measures 38 degrees. So they're telling us this angle is 38. The smaller of the 2 arcs, so that's this one right here, measures 65 degrees. What is the measure of the larger arc intersected? So this is now pretty basic. It's just, you have to draw it out for yourself. You needed to know the vocabulary, be able to draw yourselves a diagram. So now we can go ahead and do arc minus arc divided by 2, and that's going to give us 38. We can cross multiply. So 76 equals x minus 65. And then add 65 to both sides. And we get x equals 141 degrees. And our last one, in the following circle, tangents are drawn from point E to the circle such that the ratio of ACB to the measure of AB is 5 to 1. So for every one of AB, there's going to be, 5 of those. So ACB, we could say, is 5x, and AB is x. Okay? What is the measure of angle E? Well, we need to figure out what these arcs measure. Well, we have a full circle created, so 5x, we create an equation. 5x plus x equals 360. 6x equals 360. X equals 60. So we now know that, okay, well, this is really now going to be 300 degrees when we make a substitution, and this is really going to be 60 degrees when we make a substitution. Now we can go ahead and subtract our arcs. So arc minus arc divided by 2. So that's 240 divided by 2. That gives us the measure of angle E equals 120 degrees. Okay, so that's pretty much it with angles outside of the circle. It's just arc minus arc divided by 2. All right, so we'll continue with the next lesson in a couple of days. All right, bye-bye.